First of all, thank you for joining. I'm Adonis Celestine. I work for Cognizant as a technology consultant. I'm from India. I live in the Netherlands for the last 10 years working on technical projects in the Benelux area. So the topic for today is As the World Turns. So we are going to see how the world of quality assurance has changed because of the change in methodology and the change in technology. Let's start with a bit of history. So 10 years back, the way we developed software and the way we develop software now has changed quite significantly. We were working in a waterfall way of working. The developers used to write up code and throw it over the wall, and the testers, they test it and throw it back to the developers, and this went on for a while. It was quite a successful model for many years. But one significant disadvantage with this is it took a long time for new features to be put in production. So they went for Agile and DevOps to make the release faster and faster. This also forced us, quality engineers, to develop things much faster and much earlier. That's when the test-driven development, the behavior-driven development, everything came into picture. That's what I call it as a proactive way of testing while the product is being made. I call it yesterday because this practice has already been in there for like 3-4 years now. Okay, let's do a quick survey. How many of you are still working on a waterfall way of working? Okay, still a few. Okay, it's nothing wrong. It's still a very good model. How many of you are working on Agile? Okay, I see a lot of hands. But how many of you are working on truly agile way of working? I see just one hand now. It's normal. It's normal. A lot of people say that we work on agile, but we have been working on the waterfall way of working for quite a long time. Our mind and process, everything is so tuned to it. But that's yesterday. Let's look what happens today. Today, if you have your eyes and ears open, you must have heard a lot about artificial intelligence and machine learning, machine taking over humans and everything. How can we use this technology in our quality assurance? Can we further shift the process of quality assurance to the left, where we can test the software even before the software was being built? I call it a predictive quality assurance. Though it sounds a bit weird because you cannot drive a car if you don't have a car. This practice has been there for quite a while, especially in airlines industries, where they do predictive maintenance and everything. They don't wait for the product to break before they fix it. Okay, so how do we do this predictive quality assurance? That's the main topic for today. But before I go into the topic, how many of you really believe AI is for real? Artificial intelligence is for real. Yeah, it's a broad category. So one of the most popular form of artificial intelligence is machine learning. At least that's the technology we have right now. How many of you believe it is real? Okay, I see a few hands now. How many of you believe it's still on the hype? It's a hype cycle. It's just a hype. Yeah. Yeah. Still a lot of people believe it's just a hype. I personally have a strong reason to believe that AI is for real. I can give you an example of why it happens. So ever since the first computers were discovered in the 1900s, a significant progress have been made in the processing power of computers. In the 1960s, the big supercomputers were built, the IBM mainframes occupying the size of 2 or 3 tennis courts. They were able to crunch huge numbers and made programming quite simpler. But still, they had their expertise in a particular task. For example, a calculator can calculate a huge amount of numbers, but it cannot sing a song, for example. So this is what we call artificial narrow intelligence. if I have to compare it with our wonderful human brain, the human brain is wonderful because if we give an example, even when I'm now talking to you, I'm thinking about what my audience is thinking. I'm thinking about how to use this device. I'm thinking about what next slide should I play? What should I say next? So our human brain is capable of performing multiple tasks at the same time. How do we reach there? This is what we call general intelligence. So if you see in 2018, with the current processing power we have, if I have to compare that with a biological brain, it is similar to that of a rat's brain. So the intelligence, the artificial intelligence and the machine intelligence that we talk about is similar to that of a rat's brain. But the rate at which we are growing, if you know about Moore's law, Gordon Moore predicted that our processing capacity will double every couple of years. I think the rate at which we are even growing, exceeding the expectations of Gordon Moore. So the supercomputer that we have today, the Summit in US, can process at a speed of about 100 petaflops. But say in 2030 or 2040, it can reach about 1000 petaflops. That's where the level of intelligence of human brain is. And that is when artificial intelligence gets really tricky. And that is also where guys like Elon Musk and everyone is afraid of. So what do we do with this processing power? What do we process? We process data. So in the last 2 years, we have produced more data than the entire humankind has ever produced. We upload a lot of videos in YouTube, we put a lot of posts in Facebook, on LinkedIn, Twitter. So by 2025, we will have like 163 zettabytes of data. You see the numbers there? I think for a human mind, it's really hard to visualize that number. Say, if you write this data into a DVD, and if you stack that on top of each other, you can reach the moon 1 million times. That's the volume of digital data that we are talking about. And how machines use this data to achieve what I call artificial general intelligence and artificial superintelligence. Let's see that with an example. Let's say you want to predict the house prices in Vilnius. If you're asked to write a program for it, you have to write a lot of conditions because you have lots of data. The house price depends on a lot of factors like the size of the house, the location, the neighborhood, the condition of the house, etc. It's impossible to write a program which can satisfy all these conditions. Instead, in machine learning, you let the algorithms to learn by data itself. What you see on the picture on the left, the blue dots, they are all existing data. They are data for which you know the prices of the house. Let's say you want to predict the house price of the red dot there. So one of the algorithms that we use is a nearest neighbor algorithm. So what it does is, based on data, it will look at points which are very close, which are very houses with very similar attributes by itself, and it can predict what the house of the price would be. If you look at another example, I see an example of a regression algorithm. So the same price model, if there are like 2 depending variables, like in general, in a neighborhood, the bigger houses would have more price. The size of the house would be directly proportional to the price of the house. So if you have 2 linear variables like that, and if you plot the data, existing data that you have already had, and if you can draw a model out of it, if it can find a pattern, that's what we call it as a machine learning pattern. Once we have established this model, a linear line, you can basically predict the price of a house for any size of the house. So machine learning works on building models and patterns from data. Once you have an established pattern, you can predict whatever you want. But how do we use this technology in quality assurance? So what kinds of data we have in quality assurance? We have the user stories, we have the defect logs, we have the server logs, we have the incident logs. So we have so much of data that are byproducts of IT development. So how do we use this data to do predictive quality assurance? We did that in 4 steps. So if you see step one is collection of data. Though we have lots of data, we have lots of data lying in a distributed way. So we have some stuff in Jira, some stuff in ALM, some stuff in the Logstash. So the first step is to use software like Talent to extract all the information from different sources and put it in a database. Once you do that, you also do a cleanup process called reducing noise. So if there is, what I mean by noise in data is like, if it is a defect log, for example, every tester, if it is an application called ABC, probably would start the defect description with, in the application ABC, something went wrong. In the application ABC, something went wrong. So those are noises which we don't want to take into account while processing the data. So we filter out those noises, and then we split the data. We split the data in the ratio of like 70% to 30%. 70% we use it for building the model itself, and 30% we use it for testing the model. And then comes the second step. There are a lot of machine learning algorithms in the market. So most of the algorithms that we use today are from the 1970s. It is just that the processing power and the data that we have has increased, making those machine learning algorithms quite powerful. So choosing the right algorithm and building the model is a key step in your process. And once you have that model built, you use your test data set to verify the accuracy of what your model is. And once you have that, for any new kind of data, for any questions, new questions that you have for the machine learning algorithm, you can use that existing model to get an answer. So let's say we have this model. What can we predict in a quality assurance lifecycle? If you see the normal development lifecycle, you have this build, code, develop, test, deploy, release cycles. So at every phase in quality assurance, you have a quality gateway. So as soon as there is a new code change, you can understand what would be the impact of that code would be. As soon as something changes in your build, you can see what the impact could be. Whenever there is a new user story coming in, you can predict what the risk of those user stories could be. Even when in the planning stage, you can predict how much it would cost to execute this user story. So these are different ways you can predict in the quality assurance. Let me show some examples in detail. Incident prediction or defect prediction. As quality engineers, I think we are all interested in at the end to find defects. Can we predict that upfront? So if I have to predict defects, what would be my inputs? Let's say you have some user stories, you have some requirements. That can be an input. And the code itself, its data, that can be an input. So what we did, we took defect logs, incident logs from last 10 sprints. And we used the code also from last 10 sprints. And we used machine learning algorithms to find a pattern, a matching pattern. So, okay, whenever I change this Java file with these features, then I get these defects. That's a model that machine learning algorithm builds by itself. So if you see in this example, I have used user stories from last 10 sprints. And the way it works is it uses the keywords from user stories through natural language processing. To give you an example, if I have a requirement to build a login function, I would have written a user story to say, okay, it should have a username text box. It should have a password text box. It should have these many characters. And a similar defect would also happen in that release, saying the password does not accept special characters. So the algorithm makes a match. Okay, this is a user story which talks about building a login screen with requirement for password, and this is a defect which is on the password itself. So it makes this match. So whenever you go for the next sprint, when you go for the 11th sprint, as soon as some user story comes in, based on that model, it can tell you what are the possible defects it can occur. Of course, the downside of this approach is you need to have data. If you are starting this project from day one with no historic data, this will not work. So everything that we talk about with AI and machine learning needs historic data. Another example is using test data. If you see the normal test data process, so we will have a production data set, and we have a test environment. Usually the test environment is not a full copy of production because of storage and different needs. So we take a copy from production, use a query to filter out based on account numbers or based on different criterias. And because of the new GDPR regulations and everything, we probably also anonymize it before we move to the test environment. But the normal process that we follow is we follow some filter conditions. But how sure are you that it covers every possible scenario in production? So with clustering algorithms, what you can do is, with clustering algorithms, it can go through each and every column to find different patterns of data in your production environment. And it can provide you with a subset of data which has matching all key values. If you take this example here, on the first production value, you have a combination net banking, triple corporate, but you don't have that in your test environment. So if you're using a machine learning algorithm, if you are just going through each and every column, you'll get a data set which is quite usable. Another example is in predicting the requirement itself. How many of you read the customer reviews before you make a booking in a hotel or for any resort? I think almost everyone. Because these days we'll read the reviews first and then make the booking. It's because the customer feedback is so valuable and there's a lot of information in the reviews that people write. How do we use that information to drive product requirements? Let's say you are doing a product of a hotel booking website. So you can easily see what the performance issues are. There will be users who are complaining, okay, this site takes ages to load. Those are good insights. So in the next sprint, you need to have a user story which addresses these problems. So the normal analysis of customer reviews, what we call it as sentiment analysis, but we also do it a bit differently. We do it more from a quality perspective. We find out issues where there was a functional leakage, where there are performance problems, where there are real bugs in those hidden behind those customer reviews. We use that to drive our product backlog for the next release. So what do we do with all these predictions? Of course, it has to be useful for someone, right? So we built a dashboard with that. Maybe I can pull up even the live dashboard of us. So this is the dashboard, which is always on our development street. So what it gives is, it gives the development team predictive analysis at each and every step of the development. So if a developer is going to develop the code, he already has some insights of what defects they can occur, what defects they can expect. So they can prevent it instead of waiting for the software to be built and then the tester finding it. So far we are talking about machine learning algorithms and predictions as of today. That's with the brain of a rat. But what will happen tomorrow? What if AI reaches a level of human intelligence? And that's when cognitive quality assurance comes into picture. That's when the fancy things that we talk about, AI writing test code, AI writing application code, all those things will come into picture. So we have built a proof of concept of how that would look like. For example, you have the requirements. So how many of you use BDD or Gherkin statements? Okay, a couple of you. Okay, so the power of Gherkin statement is it is English-like, so all the human people can read it. It is also readable by the machine. So if you're writing statements in given, when, then, and you feed it to the machine learning algorithm, it could, based on previous history of defects and based on what the code is changed, it can automatically predict what test cases needs to be run from your automated test cases. It also triggers it, and all the self-healing and everything can be done by AI itself. And if you're talking about a simple application, it can also write the actual automation code. How we do is, if you take BDD for example, you write the requirements in given I go to the login page. When I enter the username, when I enter the password, when I click login, I should be able to log in. So this is the usual requirement that we write. There are valuable information and keywords on it, like login, password, submit button. So we use those keywords and go and search the page object libraries and extract everything, every element, technical element from the actual web application itself, and we'll use that to write the underlying glue code for the BDD part. So what we call a zero-touch automation is also on the way when we reach the intelligence of that of a human being. Okay, this is still one part of the story, how we use AI for quality assurance. But how can we test quality assurance? Why is it so difficult to test AI? It is because if you see a normal application itself, we are very much used to having deterministic inputs and deterministic outputs. So you give a condition, you give a test data, and you get a result, and you validate if it is true or false. So your input remains constant, and also your output. With AI, it's not the case. For example, if you are using Siri or Google Assistant in your phone, you can ask how is the weather going to be tomorrow in several different ways. You can say, do I have to take my umbrella tomorrow? Is it going to rain? So those are the different ways you can ask the question to an AI application. It's also the answer that you get back. That can also be quite different based on the personality of the AI itself. It can directly say the weather is going to be these many degrees. It can also say, okay, you definitely have to take your umbrella tomorrow because it's going to pour down. Also, you have like different language problems. So you can ask that in English, you can ask that in a different language. So all those has to be understood and tested by AI. These are the problems with testing AI. But the question is, what will you test in AI? So let's say you have a predictive algorithm. What would be the first thing you would test? Any question? Any suggestions? Prediction? Yeah. So what would you test in a prediction? Yeah. If it comes true or not. Accuracy. Accuracy is one of the key things that we need to test in any prediction algorithm. Let's see an example. I think most of you have seen this from internet. So they developed a machine learning algorithm to differentiate between a wolf and a husky. So what they did, they fed a lot of pictures to the machine learning algorithm to train them to understand how a wolf would look like and how a husky would look like. At the end, these were the results. If you see, it got it wrong only once. And if you talk about accuracy, this is quite an accurate model, right? Yeah, but even though it is accurate, what the machine learning algorithm was doing was, it was not actually looking at whether it was a wolf or a husky. It was looking at whether there was snow in the picture or not. So Whenever there was snow, it was predicting it was a wolf. Whenever there was no snow, it was predicting it was a husky. So it's important to understand not only the accuracy of machine learning algorithms, but also why that result is true. This can be quite critical, especially in medical applications. If it is diagnosing some critical illness, we need to know why it is diagnosing this. So there are different ways how we can test an AI. Of course, the old Turing test. Have you heard of Turing test before? Yeah, of course, everyone, right? So how Turing test works is, you ask a question to a human being, you ask the same question also to a machine. And if you collect the answers from both of them, and if you can't differentiate if it is coming from a machine or if it's coming from a human being, then it passes the Turing test. So it means it has a same level of intelligence. That's one way of testing it. Visualization. Visualizing the data and visualizing the results that AI provides is another way of testing it. I showed an example of distinguishing between a wolf and a husky. That's a classic example of why we need visualization for the results that we get from AI. Crowd testing. I'm a big fan of crowd testing myself. So with AIs, it's very difficult for one tester to test it. You send it to a group of people, especially the chatbots and all the digital assistants, and ask them to work on it to get a more trained questions and more trained answers of the algorithm. We can also use a bot, different AI to test the AI. We all know what happens when two AIs talk to each other. So it was in news about Facebook with two bots developing their own language themselves. So using an AI to test an AI, it's quite difficult at this point in time because you are not sure which one you are testing. You can also use metrics. There are different metrics like predicting the accuracy. There is a matrix called a confusion matrix to find out the false negatives and the false positives. That is also there, but there is also not a good measure of testing AI. API testing. API testing is actually quite useful, especially for digital assistants and chatbots. I will show an example of how we used API testing to test a digital assistant. So how many of you use chatbots or Alexa or Google Home in your phone? Very few. Siri. Okay, now I see a lot of hands. How many of you are really frustrated using that? Okay, so the things with these devices is it works when it works, and other times it will frustrate you like anything. So what we did was, nowadays we see more and more companies are building their apps on these digital assistant platforms. For example, if you see Alexa, there are a lot of skills in Alexa for banking. So if you see the Capital One Bank in US, they built a skill set where you can ask Alexa, hey Alexa, what's my account balance? Hey Alexa, can you give me some advice on the mortgage for me? So it is those skills that we test actually. We are not testing the device as such, but those skills. Why do we have to test it? Because the Amazon comes as a product. So do we have to really test it? So we really have to test this because the more questions you ask Alexa on a topic which it doesn't understand, especially on banking or insurance, if you are using Alexa for it, it learns based on the questions you ask it. So it builds a model which is completely different from what it was meant for. So from a regression perspective, we ask Alexa a set of questions to make sure that it always gives a proper answer for that. So in this example, we used a really funny app. It's called, it barks like a dog. So you can ask Alexa in different accents. Okay, Alexa, can you bark like a dog? And then it responds. And then you can go to the API of Amazon Alexa to capture it and to test it. I'll play the video and let me.
Ask Jurassic Bark to bark like a puppy.
Alexa, ask Jurassic Bark to bark.
Alexa, ask Jurassic Bark to bark like a puppy.
So what you just saw in the video is you type in a question, you fill in a form or an Excel with a list of questions that you want to ask Alexa, and you also want to validate the intent of those responses. So what we do is we do a text-to-speech conversion. We can, as you can see, it was on 3 different accents. It was an Indian accent, it was an American, and an Australian accent. So we feed the text-to-speech in different accents, and we'll get from the API of Echo the results and validate if it is really matching the expected results. So this is one way of testing your digital assistants. So the next time when you are developing a Amazon skill set or something, you can use this method. So what are the limitations of using AI in normal quality assurance process? First of all, the limitation is on the data itself. So tomorrow, if you want to implement this at your customer place or for your company, you will never be assured just by looking at the data if it will be a successful model or not. You have to implement, you have to iteratively use different algorithms to figure out if it will be a fitting model or not. And finding the right data is also a problem. Nowadays with GDPR regulations, it's really hard to get data out from the systems to be processed by AI applications. And there are a lot of companies that are coming up to generate data specifically for these purposes. And of course, there is a steep learning curve, and there is a lot of time required before you can implement this at your places. So how will it impact quality assurance? So how will it impact testers as such? So what do you think will be the impact of AI on your day-to-day work? Make it easy? Okay. Harder. More interesting. Sorry? Yeah. So we don't know for sure, to be honest. So if you see 20 years down the line, we don't know how AI would look like, and we will not know how if you would have a job or not. But definitely, there are certain skills we will lose. To give you an example, when we used to have those landline phones, I used to remember like 20 or 30 contact numbers. Nowadays, I don't even remember my wife's phone number because we don't have to. Everything is in the phone. So the more and more we are getting used to technologies, the more and more skills that we use. So how many of you can do some really complex calculations these days? We really reach out for the calculator. So our sense of arithmetic skills are also going down. I think there was a research from Kaspersky's lab where they said with more and more use of technology, the human brain is going down and down because we are pretty much reliant on the technology itself. That, according to me, would be the biggest impact of AI also in quality assurance. That's it from me. Thank you.